welcome everybody here to Humboldt Redwood State Park. I probably talked to a lot of you when I was roving through the campgrounds, but we have a special presentation for our campfire program this evening. We have two experts here to talk to us about albino redwood trees, and I'd like you guys all with a warm welcome, invite Zane and Tom Stapleton to the stage. Thank you guys.
Cool, thanks. So I'm Zane. I'm a student at Colorado State University. I've been working on albino redwoods for now 5 years. And then you can introduce yourself.
Yeah, I'm Tom Stapleton. I'm a certified arborist, and I do what's called genetic archival of rare redwoods, and specifically a albino redwood variant here that we have on display. These trees are extremely rare, and in nature they could come and go, so to speak. So what I do is I propagate them so that we can study. There's already been some of these albino redwoods that have died, and by having the genetics in trees to propagate from, that we can do further studies. So
cool. So we've been collaborating for 3 years now, and a lot of all these discoveries have come from our collaboration. But first, we'll how many of you have heard of an albino redwood? Anyone? Okay, a few of you. So, even for people who live in the redwoods, there's a lot of people who don't know what these are. Everyone can hear okay?
Yes.
Good. There's a lot of people, even locals, that have no idea what's going on. I even talked with, there's a grove, Richardson Grove, 30 miles south of here, where a docent, a volunteer for that park, it's a redwood park, had never heard of these, you know.
now we call them ghosts of the forest not only because of their color, it's because they're also very elusive. So you could, like Zane was saying, you can have an expert walk right by one, and if you're not looking, you wouldn't even see it. So.
Wow.
So this first picture shows an albino redwood in the forest, and I hope you all can see. This is the albino redwood. It has white foliage on it, and yeah, so they look kind of barren. They look kind of ghostly, I guess, because of their foliage. They almost look dead, but they're alive, and so that's a strange oddity about them. And here's another one. You can see this is me for scale. This tree was known since about the 1950s. Okay, so these redwood trees, these albino redwood trees, have been known since 1866. This one's 60 years old, about, and it's in the park. But there are other ones that are much, much older. And what really makes it weird that they can grow so old is the fact that they can't photosynthesize. So what is photosynthesis? What does it use and what does it take? Yes?
Uses oxygen, or no, CO2 and produces oxygen and creates like a carbohydrate source.
Yes, yeah. So it takes carbon dioxide out of the air, and using sunlight and water, it can produce food for plants. So what makes albino redwoods really weird, you can take this.
What makes them very strange is that they cannot survive on their own. They don't have chlorophyll. Chlorophyll are the green things in the leaves which produce the sugars. So that's completely absent. So that's why the albino redwood looks completely white.
Yes, question?
So do they form like a symbiotic relationship with the other?
Yes, yeah, we'll get into it. So because these can't photosynthesize, they aren't photosynthesizers. So because they aren't photosynthesizers, they need to get their food from somewhere. So where do they get their food from?
The parent tree.
So you all noticed when we talked about sprouting in redwood trees. These are, you want to take some?
That's fine.
Yeah.
These are basal sprouts that you see in the forest, and normally, 99% of the time, you'll see them as all green. So what they serve on a normal redwood tree, you can see the green ones here, is if the main tree gets cut down, these sprouts will take over from the root system and form a new tree. But here, the albino is absent of the chlorophyll. It doesn't have any ability to photosynthesize. So this is why you're having this white sprouts here, and it's getting its energy from the parent root system. So that's why you're thinking maybe, well, how can it survive if it doesn't produce its own food? Well, it's living parasitically off the parent.
Yes.
So these ones look like they have some chlorophyll and some not.
Yes, these green branches are actually supporting the albino branches down here. This redwood, believe it or not, produces two types of branches. We can see the green and the white. They come from different layers within the tree.
And
So-
you all are welcome to come up here. Like this presentation will be short, so you have time to come up here, ask questions, examine these trees. So yes, some of them can survive. Even here, that you can see there's a dead redwood parent tree, but the albino redwood's still surviving. Anyone have any idea what's going on here? Yeah.
There might be still leaves from the bottom of the trunk, and it's still
Yeah.
Yeah.
Yeah, there could be a little bit of leaves, but this tree is 15 feet tall, so it needs more sugar than just a few leaves. There's not really much of anything down at the bottom. Any other ideas? How does it get its food?
From the roots.
From the roots. Yes.
That's right.
So redwoods are a really special species because I don't know if you have heard this, but their roots are very shallow. They're only 6 feet deep. But those roots can graft together and they can share their sugars.
Energy. They can share the energy between the other redwoods. And they form like a netting underneath that actually aids to the stability of the trees in the forest. So as there's large windstorms that come through, we're able to draw on the other roots as support. Not only for nutrients, but also for support.
So the redwood forest is much like a community. So then the question is, so trees, they can actually control where they put their sugars, where they give their sugars to, and they can sense whether or not the trees are being useful of their sugars. So with this tree, it doesn't photosynthesize, it's not being helpful to the parent tree, or at least so it seems. Is there any idea why this might exist? Why would the tree keep these things alive for a long, long time? And even trees in the forest community keep them alive. Anyone have any ideas?
I have no idea.
Okay, so good. So keep that in your head. We'll keep going through this, and you'll have a better understanding when we're done. So you want to talk about the variegation?
Yeah. So there's about 25 of these that exist in the world where you have a normal green branch that starts having this variegated pattern. So
Variegated means two colors,
two
green
colors.
and white.
Right. As you can see here, you're getting the fading effect and it's splitting between the needles here, and then this is becoming albino. So this is able to produce some of its own energy, and here it is not. So there's some photosynthesis taking place within this variegated branch, but it still needs to derive its energy off the parent. So this particular type of albino variegation is very rare. Like I said, there's about 25 of these. Now, as far as albino redwoods go, there's we've documented a total of around 330, and there's out of that 330, there's only 25 of this particular variety.
330 in the
This is
world?
330 in the world, yes. There's 56 of them in this park.
Naturally. Yeah.
So this park has about a fifth of all naturally occurring ones. There's 270 naturally occurring. There's some that are planted, but 270 naturally occurring. Here's another type.
Yeah. Now, the other one that we just saw before, the variegation had that faded effect that you saw. look at this one here, that there's very clear borders where you can see that there's a white needle, green needle, and even a needle that's split between the albino and normal green. So think about in your body, you have DNA. Well, this particular albino has 2 sets of DNA. And the white is one, and then the normal green is another set of DNA. So it has 2 sets. And you can see that as like a line or a tracer, see how this green goes off? It's kind of like a freeway off-ramp, kind of splits off, this disappears. This green gets carried here, comes down, and that variegation continues on, and you can see that it's very clear. This is called a chimeric redwood, chimeric albino redwood, and I'm not sure if any of you heard that there was a tree down south in Gitati that was saved. That was part of the 10 that was recently relocated.
They're very, very rare. There are 6 of them in this park. And this whole talk, a lot of it, because these are somewhat fragile and you can pick them and kill them, we can tell you where some of the higher up aerial albinos are, and we'll talk about those and show a picture in a second. But for the low down ones, just to make sure that they're safe, the park has asked us not to share those locations. But if you happen to run into one of these, just realize that these are more rare in this park than really, really tall 350-foot redwoods. These are really, really rare. So if you find something like this, or any albino redwood, just realize that it's something really, really special.
Yeah.
And even on the popular trails, you might see one. So just keep your eyes out. Yes. What's your
When
question?
were albino trees discovered?
They were discovered in 1866. So over 150, or about 150 years ago. And there's still a big mystery. Like, we're trying to figure out the mystery. We've made a lot of progress, but there's still a big mystery.
That's the question.
Yeah. And this is, so albinos come in 2 different forms. There's aerial, up in the air, and then there's basal down the ground as sprouts. This one here is taking the shape of a branch, and this one is located in Founders Grove behind
Bull Creek Flats.
Bull Creek Flats, and it can be seen from the road. And you can see this one. So if you walk the road about how many?
It's about midway down. The road's about 4 miles through the redwoods, maybe 2 miles. It's by a 25-mile-an-hour sign. Look out into the forest and look for this. It might be glowing a bit yellow. This was kind of white on a cloudy day, but since it's sunny, it might be kind of yellow.
So it's best to see this in the morning where you don't have all the light coming through the canopy, or on a foggy morning where the fog's up above. So this is really pretty. I mean, it's this picture doesn't do justice.
So sorry, is it just that cluster that's albino and the rest of
Yes.
the tree's not?
The rest of the tree is green. This is a tree over 300 feet again, and the albino is about 150 feet up, so like halfway up. So it's way, way up high.
And I just want to say, albino redwoods can also be off-white, where they kind of look like a cream color or even
Yellow.
bright yellow. Yellow is your cow shirt right there.
So here's an example of a yellow albino. Do you all see it? Right there? Do you see that yellow splotch? This albino redwood is the highest up in any tree known. It's 280 feet up in this 328-foot tall redwood tree.
And the reason why it's yellow is because it gets a lot of sunlight. So what the albino's doing is it's producing a pigmentation that gives it this color. It's kind of like sunscreen. So to protect it from being burned up in the sun, it gives it this yellow coloration. If this albino was way down in the forest below the canopy, it'd most likely be white.
How do you find that?
How do you find that? So I have a friend who has just amazing eyes. This is about the branch. We can measure it using lasers and equipment. We can measure that it's about 1.5 feet. And so with a branch like this, 280 feet up, that's taller than any of these redwoods that you see over to the side here. That would be higher up than that. To see a branch this big, the guy just, like even when we knew where it was, it's like you're looking.
We
it's
were
like,
just still blown
how do you
away. I mean, to
that?
see that, and you have to be. What's interesting about you have to be at exactly one spot, looking at this particular angle
With
to
the
find
right
it.
light.
So, go ahead. You had a question?
Yeah, I was just wondering what the actual definition of albino was. I thought that it was can't
Chlor-
produce any pigment or something, but you said that this albino is producing yellow
It's a
pigment.
chlorophyll deficient mutation, is what the
So
technical term.
yeah, with
Or
the
I mean, just general. I mean, maybe not just redwood
Okay.
albinos, but all
Okay.
albinos.
So botanists, I'm a botanist. Albino is a term used in quotes. So what an albino actually is an organism that can't produce the pigment melanin, which is what makes our skin, gives our skin color, which is why albino humans are pure white, you know? So melanin's only produced in animals, so technically you can't have an albino plant. But this has been the common terminology used for 150 years, so we're just sticking with that for the ease of everything. But when you consider a plant, its main pigment that it produces that gives it color is chlorophyll. That's why they're all green.
Right.
So with this plant that can't produce chlorophyll, or this branch, that's why we're calling it an albino redwood. And that's why it's been called that. Yes.
Go ahead.
The only kind of albino redwood only in California.
Can you only find them in California? You want to answer?
Well, we've got a report of one in Seattle, Washington. And when Zane and I found that out, we were quite blown away, and we got photographs of it, and it's quite remarkable. It's a planted redwood, and the albino is growing up way up on a branch. It's probably, I'm going to say it's 6 by 6 in size. It's very large. So they can be wherever redwoods are planted, they can be found. It just depends on the local growing conditions and some of the theories that we have that what initiates the mutation or the albinism to start. Good question.
Okay. This albino redwood, you can see me and Tom standing here. Can you see that?
Yeah.
Okay. Yeah, because I can't see it from this angle. So this is actually the tallest known albino redwood in the world. It's in this park near a popular area. So if you ever, again, look in the forest. They kind of appear half dead, and that actually has to do with the fact that these albino redwoods are not very good at holding water. They release water really easily, so especially on these hot days, they're going to be releasing way more water out of their leaves, and maybe even look wilty and kind of like that. Kind of not so vibrant. Even though the parts that are alive, the white parts, are very vibrant. Okay.
Right here.
Yes.
I think that if you two were stacked together, it would take like 10 or 20 of you guys. Just stack together
Oh,
on each
yeah,
other.
if we stood up, so this tree is 50 feet tall, so it's about like eight or 9 of us, yes, yeah, if we were standing on top of each other.
That'd be like this building twice as high, basically.
Yeah, yeah, over 2
Or
times.
twice as high, yeah.
Yeah, maybe like 3 or 4 times
Yeah.
the height of this building. Yes.
So I think you mentioned it. So are they considered parasitic?
So yes, we're gonna, yeah. So now the question is, what are these things doing in the forest? Why do they exist? It's been a mystery for 150 years, but we have a pretty good idea as to why. It took 3 years, as we've talked about, to figure it out, of intense research. But we think we've figured it out. And it actually has to do with human impact, has a decent amount to do with it. Also, different types of soils. Different types of soils have different chemicals within them. And some of those soils have chemicals that are almost seen as pollutants that you would find in like oil, for example. Who knows what shale is? You all know what shale is? Where very layered rocks, where you see a bunch of layers. Those types of soils contain high amounts of of heavy metals or elements that we would normally see in oil or diesel or pollutants of some sort, not just fossil fuels, but pollutants. So in this park, the reason why this park has a high number is because a lot of the soil around here and that gets carried by the Eel River and deposited onto these flats, a lot of it is from shale sources. So, so do you want to talk about the sucking up?
Yeah. So what happens is that in these shale soils, the trees start sucking up those minerals, and they start accumulating in the tree. And they get to a point where, when a mutation occurs, they start building up in albinos more prevalently than in the green foliage.
The toxins do.
The toxins do. So what's interesting is that what albino redwoods do is they precipitate out the toxins. The toxins build up in the albino foliage. The foliage dies, and it acts like a salt burn, so to speak. So these minerals accumulate to a point where they're toxic, and then they die. So that's why there's a lot of, if you look at albinos, there's like a lot of dead foliage with inside the, yeah, go ahead. Yes.
Okay, so basically, if you pour a bucket of oil near a baby redwood, you get an albino.
Not that easy. Not that easy.
You want to explain why?
The reason being is because the concentration of dumping oil in one spot is so bad that what will happen is it will kill the tree. It has to be, the toxicity has to be gradually over time building up in the foliage. Like for example, on these trees here, when I fertilize them with micronutrients, what will happen is that these green needles love it. They photosynthesize, they take the micronutrients, and they become healthy and green and produce more branches. Now the albino portions down here, it's just the opposite. They don't like it. What happens is that those micronutrients build up in the albino foliage and produce a burn. It's like a salt burn, and then the branches die, they drop off, and those particular branches and the needles that are dead have locked in those micronutrients that no longer can be precipitated out. So what the redwood is actually doing, which is interesting, it's cleaning the soil. So whatever toxicity that is in the soil, it can draw it out and no longer make it available for other trees around them. So in some ways, albino redwoods are cleaning the environment. I mean, it's an interesting way to look at maybe what would be a benefit for redwoods producing albinos in the forest.
So then the question of, are these parasitic or are they symbiotic? Well, they're parasitic when you consider where is all the sugar and where is all the food. Like, the plant has to allow these to live. But if they do live, they do a pretty good job of cleaning up the environment. And what will happen is, because these can survive under really harsh conditions, they can get really, 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 really big if that environment basically is toxic enough that it's worth it for the tree to make it very big. Or they can become very small. Even like when the cleanup job is done, they'll start to become smaller in size and they can even disappear. Yes?
So what about the aerial albino redwoods? Are those same nutrients, those same elements are going up the tree and then being sorted out and stored into those albino redwoods way up high too, or is it just the basal?
So redwoods are a very special species in a lot of ways. And one of the ways is they do what's called foliar absorption. Their leaves can suck up water, but they can also suck up toxins in the air and different things like that. So you want to explain why?
Yes.
About the toxins in the air?
Right, exactly. Now, albino redwoods can be seen not only in the natural range, but in the planted range. Like when I say planted range, I'm referring to the Central Valley of California, like Sacramento, Bakersfield, and those areas. And what's interesting is we're seeing a correlation of albinos on the trees facing a certain direction, like either the south or the southwest. And it's turning out that that's not only the prevalent sun direction, that's also the wind direction. So as the those of you that are familiar here with California, you have the winds come through the Bay Area and they fan out through the Central Valley. Once they hit the Delta, some of the air goes down south toward the valley and some of the air goes north. So what we're finding out is albino redwoods that have been planted in Chico, they're on the south, and then some of them down south in like Merced, they're facing north, and it's basically the albinos are forming on the side of the tree on the prevalent wind direction. Now, why would that? Does anybody have an idea of maybe why that's occurring? What does the wind direction have a correlation to where the albinos are located on the tree?
Is the polluted air that they're
Yes,
sucking in?
absolutely. The Central Valley is known for carrying all the Bay Area pollutants into the different sectors of the valley. And so what happens is that since we have a Mediterranean climate, we get hardly any rain during the summer, the pollutants get absorbed on the tree all summer long. And so what happens is that as the redwood tree is transpiring, allowing water into the atmosphere, it's also, like Zane's saying, absorbing moisture. And it's also we're suspecting that it's drawing in those toxic elements, the same thing that you would see down in the soil. Like from the shale, we're thinking that's also drawing it out of the atmosphere. And so that's what we're studying. We're wondering, okay, what is this pattern between the albinos in the Central Valley and why are we seeing them on certain sides of the tree? And we're starting to understand that wind is starting to point us in that direction.
Yeah.
I'm not sure who was first.
So, if there's no chloroplast there, is there a substitute? Is there a mutant there? What's the chemistry going on?
Okay, so chloroplasts are little bodies within a cell, and the definition of a chloroplast is a plastid, which is the name for these bodies. They're called plastids with chlorophyll. So a lot of these trees will have plastids. They basically have chloroplasts, but without any chlorophyll. So it's like vacant rooms sort of in a hotel for a cell. And those chloroplasts without chlorophyll, they're white. So they're called leucoplasts. Leuco means white. So so it's kind of weird to describe plastids as whatever's inside of them. That's what we call them. But yeah, they're called plastids, and these do have plastids. They just don't have chloroplasts. They have leucoplasts. Yes.
I think my question is similar. I thought you said earlier that the genetics are different in the albinos. Is that right?
Yes.
So are you saying that the environment changes the genetics?
No. So the environment, so that's a little bit confusing, and yeah, we're trying to make it so that it's easier to understand. So the question is, again, kind of like your question, if we just pour oil on it, will it become albino? Well, the mutations occur randomly. They're going to occur where there's more sunlight. They're going to occur where there's more, like similar to us, like we'll get skin cancer in the sun, for example. So in areas with high sunlight, skin cancer is a mutation for us. Plants have the same thing. They'll get a mutation. So what we're saying is these mutations aren't caused by the environment or by like what's in the soil, for example. But if the mutation does occur by chance, that soil will allow that mutation to proliferate and get really, really big, really, really fast. If it's good, like if it's maybe when I say good soil, it's if it's bad soil, good soil for albinos.
So does anybody want to take a guess of maybe why this albino is proliferating in relation to this railroad tracks? We're suspecting.
Oil.
I think it's because of the metals in the train tracks.
Kerosene. Kerosene has a lot of heavy metals like nickel, lead, mercury, zinc, copper. There's a lot of that gets into the root systems, and plants are very sensitive to that. Albino redwoods are not as sensitive, and they can take in that. So yes, it doesn't cause it, but if the tree does have this at random, heck yeah, the tree's going to use it. It will use that because it allows for the green redwood to do better. Just like with the fertilizer test, you give it a lot of fertilizer, the green will use that fertilizer, but it will burn out the white because the white's so used to just sucking up everything, like we were talking about.
You got a question?
Sure. Are there more than one albino redwood along those railroad tracks?
Is there more than just this one on that particular set of tracks?
There's one a few miles down these tracks. And then there's also some a little bit further away. Like these are, you can see they're like it's about a foot away from the tracks. There's one other one like on these tracks that's a foot away from the tracks. But there's a lot of them that are like within 20 feet, 30 feet. Yeah. So they do correlate heavily with railroad yards. You want to talk about Roseville?
Yeah, in Roseville, which is a suburb of Sacramento, what's interesting is what we found is that on the southeastern side of this rail yard, there's a whole bunch of albinos, but there's
Downwind.
Downwind. Exactly, and there's about 5 or 6 of them in all these planted redwoods.
Yeah, out of like maybe 10 planted redwoods, 6 of them, 6 out of the 10 have albino, like
Right.
just a bunch of albino redwoods in almost every
So
tree.
you think of the proportion of this park of how many millions of redwoods there are versus how many albinos, and then you go to Roseville where, like Zane said, you got 10 redwoods and then you got
A
6.
majority.
Right, and you got 6. There's something there. You can see that obviously that with the prevalent wind direction, pollution, especially all that diesel. Diesel produces all kinds of heavy metals and different. Go ahead.
Did you say that the redwoods in the Central Valley are transplants?
They're planted.
They're planted.
They're planted. So here's an interesting thing is, in the late 1970s, all redwoods that you would, well, before the late 1970s, all redwoods that you would buy in a nursery were all planted from seed. That means that they had a burl and they would sucker and produce sprouts. Because people felt that was undesirable characteristic of redwoods, what they did is they started growing cuttings after that point. Basically, they would take sections of a tree and propagate that and become a new tree and sell those. So what I'm tying this into is most of the trees in the Central Valley don't have any basal sprouts. So you see the albinism on here.
And taking cuttings, basically what all that is you snip off a little green section of a tree, put rooting hormone on it, and have it create roots, and it produces a genetic copy. That's how these trees were made.
Yeah.
And if we wanted to make more of these trees, that's what we would do.
Yes, exactly.
So how old are those ones?
These here are about 3 years old. This one's about 3 and a half. And you can see that given the right conditions, that they can grow quite quickly. Here you have the albinism. This is like lime green on this tree. You can see it spread throughout. This is a genetic clone of the Katati tree down there in Sonoma County. This is a 45-ton, 52 feet tall redwood tree that was in a railroad right-of-way that was being threatened to be cut down. It was one of the 10 Chimera albino redwoods. It was in a special category that the tree was saved, and they actually had to move it, transplant it, and move it to another site. So this is a genetic copy of that tree.
So just to respect everyone's time, we want to, we have a few more slides, and then we'll say thank you, and then if you want to go, feel free. So this, who knows what this plant is? This is an albino plant, but who knows what it is?
I think it's a clover.
The albino plant.
Yeah, I know.
The albino plant's not a clover.
Oh.
You normally see these green, yeah?
Poison oak?
Poison oak.
Absolutely, yeah, perfect.
This is poison oak. So there's a lot of poison oak in this park. And what it looks like, it'll be green, not white. But what it looks like is it has leaves of 3, and the leaves kind of look like clouds. I mean, they aren't going to be white, but they're going to be green clouds. But they kind of have a wavy look to them. This is poison oak. Who knows what happens with poison oak? Yeah. Good, everyone knows. You get itchy. And it's after a day, so you won't realize you hit it until a day after you leave the park. So just be aware of poison oak.